Hello, good morning, good afternoon, good evening, wherever you are in the time zone. A very warm welcome to this multi-part webinar about securing AWS environment uh, from Cloud Optics. A few housekeeping items. To ask any questions, please click on your question button, and presentation slides will be provided over an email to all the participants. And most importantly, the feedback. Please do not forget to leave the feedback. It's very important for us to understand your interest levels and what new items or topics you would like us to cover going forward. So please do not forget to leave the feedback. A bit about myself. My name is Asim. I'm founder and CEO of Cloud Optics. I have about 20 years of IT experience and worked in companies and startups in California and Fortune 20 companies in US. More recently, I was heading cloud security operations business for Wipro Technologies in India, and I was instrumental in establishing cloud infrastructure security business and scaling up and offering cutting-edge solutions to global customers. Now let's dive into the presentation. Before we get into that, I'd like to get a view, a quick poll, and see in your organization how you guys are using the workloads of the public cloud. So on your screen, please start voting. We'll give it a minute. The question is, which public clouds are your workloads primarily deployed on? AWS, Azure, Google, elsewhere, or we do not use public cloud? So responses are trickling in. Let's just give it a minute. Another few seconds. Please vote on the screens, and closing the poll now. All right. So it says about AWS is the most used platform. So moving on to the next slide, which is about the AWS context here, right? So why are we talking about AWS? AWS is the most widely used platform, and it is by far the largest in terms of revenue and multiple dimensions. We'll see other dimensions as well. But if you look at the quarterly revenue from, say, Q1 of 2014 till Q3 of 2017, it has grown from about $1 billion to $4.5 billion. That's a phenomenal leap of revenue jump on the AWS side. So that's by far the largest in terms of revenue in IaaS field. And if we look at from the market share perspective as well, and we see all the cloud providers are stacked on the market share. AWS is about 35%, and the annual growth rate is also pretty high, but not as high as Microsoft Azure, which is clocking highest growth rate, but the base effect is pulling it down, and the size is a little bit smaller than AWS. Now, in summary, if we look at next biggest, Microsoft, Google, IBM cloud put together, AWS easily is bigger than them combined. So AWS is definitely 800-pound gorilla, and it's most widely used cloud service out there. Now, if we look at the service offerings from AWS as well, as per AWS analyst reports in Gartner, this is the highest rated service as well. So whether it is for marketplace, for application deployment, and the custom application movement, etc. This is AWS is still the highest. So given the wide adoption, we need to, it's very topical that we talk about AWS security and how to make AWS security work for the customers and information security professionals like ourselves. So let's look at the security context here from AWS or IaaS in general. So the way cloud security is structured for IaaS and other PaaS or SaaS delivery model is it's a shared responsibility model. So what do we mean by shared responsibility? In shared responsibility, there are a compute stack which is built of physical facility, compute, network, storage, server virtualization, operating system, middleware, application databases, and data. Now, for IaaS providers like AWS, the level of responsibility ends at server virtualization, and beyond that, it's operating system, middleware, data, application, databases, and data is responsibility of the customer. So it's very important that customers understand the requirement of security and take appropriate steps to secure their workloads on AWS. So today, what we are going to do is we are going to cover IAM, S3, and CloudWatch. AWS has very wide variety of services and too many security options. Of course, we can't cover them in one webinar in a 30-minute slot. So today we are going to cover certain portion of IAM, S3, and CloudWatch, and then other services we are going to cover in probably more detail in next subsequent editions of this webinar. So from IAM side, our first recommendation is that we should utilize AWS Identity and Access Management Services. So what is AWS Identity and Access Management Service? Access Management Service is comprised of users, groups, roles, resources, and policies. So the policies are assigned to resources, and then those policies can be assigned to either users or groups or roles from a management point of view. So a user may be given certain access rights, like maybe you can see security groups or EC2 instances, etc., or you can make changes to it based on your authorization level. So that's the way the security is configured here in AWS platform. Now, what is the use of it, right? It helps us create inter-service communication across access provisioning, etc. So for example, if a service running in EC2 wants to access some other service, then we should utilize AWS access management layer to provision that access and control that. And this helps us put very fine-grained control over services and prevents unauthorized access. So it's very imperative that from a starting point itself, we use this very important service, AWS IAM. Now, second recommendation is on the password policy. What is password policy? So a password policy talks about enforcing the password complexity. For example, the good password practices suggest that a password should be big, which should be maybe a 14 character or maybe 16 character, depending upon what the organization policy states. And those characters should be a mix of uppercase, lowercase, numbers, special characters, and so on. So that's setting up those parameters comes under password policy. Now, by default, it does not come enabled in the account, so we have to go and manually set that up. And that also deals with the rotation of the password every 30 days, 60 days, or 90 days, whatever the business requirement is. And those kind of password reset rules, like how many passwords can be stored in the history, and 5 to 10 passwords, and so on. Okay. So setting up the password policy and this kind of rotation and complexity rules helps in compliance controls like HIPAA and PCI. All these regulatory standards talk about user accountability, and if the password gets compromised or they are not rotated frequently, it creates a risk of data loss and having the old unauthorized access coming back to the account, and data exfiltration may happen. So it's very important that we enable the password policy, and we continuously also monitor this as well. Moving on to the next item, removing root account API keys, right? So once we sign up for the AWS account, we get a root access, right? That first user ID has a root access, and we should be very careful in using root account, because root account is actually like a team account where there's no accountability. If we enable the logging, etc., or access tracing, what we will see is that it will say only root. Now, who that root is not visible. So for that reason, the personal accountability of the user using the root credentials is lost. So the best practice, as per best practices, we must not use root account, and on top of it, we should not create these API access keys. So API access keys are created for programmatic access to AWS services and interaction. And if root account access keys are created and then distributed, that becomes very, very challenging to trace back and find out what's happening, because root access is pretty much a super user there in the account, and they can pretty much practically do anything they want. So for this enforcement of best practice security practices and preventing unauthorized access, root account API keys should not be created, or if they have been created, they should be removed. And it should be regularly monitored. So regular monitoring is really the key here, because we may set up the account, or we may set up certain security practices once, but it does not guarantee us continuous security going forward. And however account or data is protected every hour of the day, right? So now our next recommendation is utilizing IAM groups for fine-grained access. So as we were discussing earlier on IAM side, that IAM contains entities of users, groups, roles, and policies, etc. So policies can be IAM AWS managed, like read-only policy or some other policy based on maybe a functional role as a system administrator, developer, and so on. Or we can have these policies attached to a group and then make users part of that group based on certain role or maybe certain function. So we may create a group which talks about, say, developers in finance department. Right, and any access which is required for finance department developers will be given to that group, and then users may be assigned to that group as required. So this is a very fine-grained management control here, because as users are moving from department to department, let's take an example where a user is moving from finance to HR. Now we have two groups of say developers, finance and HR, and they have respective access assigned. Now, if a user is moving from one department to another, we simply swap the groups and we are good to go. However, in other case, if we try to do a direct mapping of policies to the user accounts, then it will be very hard to remember, collate, and manage which policy remains and which does not, and users may be left with either too much access or too little access, creating problems. And similarly, when the user is joining a new group or maybe new company, it's very easy to assign groups and give them entire set of privileges based on their need. So this particular practice helps preventing privileges sprawl, where users over the time accumulating too many privileges as they get older in the organization, and they spend many years, they accumulate privileges. That typically happens in any organization currently. But in AWS, if we follow the best practices, we can prevent that privileges sprawl and accumulation, and keep the environment secure here. Now we'll look at CloudWatch alarms, some of them. So we'll first a little bit explain how CloudWatch works. So if we are having AWS events which are being generated, like maybe a login happening on AWS or something else is happening, some API is trying to access AWS services. And when we enable CloudTrail, all those access attempts and authorization, authentication, etc., gets logged into CloudTrail logs, which are stored in S3. Now, CloudWatch service works on top of these logs, where it can monitor the metric, particular maybe pattern or a rule, and then there is an alarm which talks about if we identify certain pattern in certain time frame and how many number of times, maybe 3 times or 5 times. Let's take an example of a failed login. Somebody is trying to log in the AWS console, and that password failure or something happens. Now that will get logged into CloudTrail, and from CloudWatch we can always configure a rule which says, all right, pick up the metric which says authentication failure, that's the event, and if there are 3 failures within 5 minutes, send an email out. So that kind of configuration we can do using CloudTrail and CloudWatch. So we are going to focus on CloudWatch, what type of alarms we need to have for best security practices in our environment. So let's take a quick poll here and see what is the organization's cloud readiness security position here. Right, so you can go ahead on your screen and vote. We'll give it a few more seconds. All right, last few seconds. Okay, all right. I don't see results here for some reason. Not sure if there is a technical issue with BrightTalk. All right, so let's focus on CloudWatch security. So first recommendation we have is for billing alarms. So we need to set up billing alarms for identifying DDoS attacks. So we all know what DDoS attacks are. It's a distributed denial of service where somebody generates a malicious actor or entity generates phenomenal traffic directed towards a particular server or maybe entity or a domain, and the objective is to overwhelm that server or that service with so much request that it cannot serve legitimate users as well and appears offline. So in cloud world, it may rake up huge bills because we configure our servers and applications, etc., with auto scaling, which means if a more and more traffic is coming in, then the cloud infrastructure will automatically put more firepower in the machines and everything to serve those many requests. However, what is not known or understood is whether that is a legitimate business spike or it is a DDoS attack in progress. So to identify that and alert users, we recommend setting up billing alarms. So what that billing alarm will do is there will be a CloudWatch metric data which will be estimating the usage charges. So for example, if we are expecting certain, maybe a promotional period or something, and our usual expend is about say $100, and based on our estimates, now we make it to $120. Then we set up the billing alarm for say maybe $125 for to be on the safer side. And then if there is some unusual spike comes in, this billing alarm will be generated and a user will be notified. So before a DDoS attack can kind of misuse the auto scaling features and generate huge bills, some human being will get notified and they can take appropriate action, review it, and see whether they need to increase the quota or not, or whether it is a legitimate business spike, then they can take appropriate action or not. So that's very important that we set up the billing alarms here to find out DDoS early on. The other recommendation we have from the CloudWatch alarm side is the authorization failure. So we need to keep track of authorization failures. So if so, the way AWS APIs work is that any access will get authenticated and authorized both. And if there is an authorization failure, it gets logged. Now, if we monitor that authorization failures, we will be able to know that some user or maybe some requester from a particular IP address or a particular ID is trying to elevate their access and trying to access which they don't have access to. So we can find early attempts of such requests, and we can take appropriate actions before it gets out of the hand. So we can always configure rules such that please alert if you find 4 or 5 authorization failure requests within say a 15 minutes period or so, or maybe 30 minutes period, depending upon how we want to, how aggressive we want to monitor the situation. Customer master key changes, so alarms to detect. So this is very important. This has something to do with encryption. So for example, we all use encryptions for securing data at rest. And the way we do in AWS is using customer master key encryption keys, which is CMK, it's a short form they call it. Now, if an account is compromised, or maybe credentials are compromised and data is already encrypted, the first thing attacker is going to do is rotate these keys. Because they won't be having the access keys and all that, because it is with the person already. So they won't have access to it, and first thing they will do is they'll try to stop the old keys, put the new keys in, and delete the old keys and so on. Those kind of steps will be taken. Now this will help identify, if we set up the billing alarms, it will help us identify the account compromise in progress. So that's something which we can do it very quickly, and it will not go unnoticed. That's the benefit of putting this configuration changes notification in place. Now let's look at the next one about enable CloudWatch alarm for console authentication failure. So if we are not using any third-party products for logging into AWS services, maybe a cloud orchestration engine, etc., and we are using console directly, then of course there is going to be console logins via these administrator maybe, or a developer who is trying to spin new machines or trying to do some other work they have to do. Now there's a possibility that since console is open to the world, people may try to do a brute force attack on console. And once the ID is known, they can always try to put all those combination of passwords, etc. Now that's where, first of all, first line of defense is password complexity rules. If password is complex enough, it will take a long time to do that. Now on the second side, second angle of that is that on the back end we can set up these kind of authentication failure alerts. So if an authentication fails, then the CloudWatch alarm will pick that up. And our rule may say something like, if you see console authentication failure, 3 consecutive failures within 5 minutes, please alert. So with that alert, we can very, very quickly identify that there is something going on, or maybe it's an inadvertent mistakes, no harm done. We can at least know about it. So this is these are very important alarms to set in CloudWatch to monitor the account properly and secure it very, very quickly and early on. S3 security. So this is S3 buckets, as we know, are the places for storing the data and sharing maybe with third party and vendors and whatnot, or maybe just for internal purposes. Now, this particular S3 buckets have been source of phenomenal compromise over the years in AWS environment. If we go back and remember a couple of incidents which happened, maybe Republican data, voters says 200 million users data was compromised from Republican Party, and there were many such incidents where data stored in S3 buckets were compromised because they were publicly accessible, right? And so there are multiple ways of having this publicly accessible. One way, of course, we know is we don't put any restrictions on it, and so we are not going to talk about that, but we are going to talk about something else, which is authenticated full control access. What is that? So the way S3 permission model works is that you can set up, or a user can set up S3 bucket permission for all authenticated users. So what does authentication user mean? Any user which has authenticated itself to AWS console. So it could be unrelated account, unrelated user completely from the S3 bucket ownership in question. But because the bucket is set up as full control to all authenticated users, any AWS users in the universe can access that bucket. That's how powerful this setting is. So we need to revoke this access, and we need to continuously monitor it in case our buckets are being created and new data is being uploaded onto S3 buckets and so on. So this is very important to monitor on a regular basis. So this will prevent any unauthorized access to S3 data and not result in a data loss situation. Now, versioning and logging S3 access. So these two are very important features. Logging is related to logging all the S3 bucket access, which are there, right? And versioning is about if the data update is going on, we are updating the data maybe a weekly, monthly, or maybe ad hoc basis, then maintaining all those versions. Why is it important? So logging is important to make sure we can audit the information, who has access to what. There could be a challenge or a problem or mistake in permission model, which allows S3 bucket access to unauthorized persons or unintended persons, which we will be able to identify if we are doing the access logging and auditing of that access logs. Versioning will help us set up or recover the data in case it is accidentally deleted. So if all the versions are maintained and there is an inadvertent mistake and the data gets deleted, then we can very, very quickly restore the data and prevent incidents from creating havoc in organizations. So these two, versioning and logging S3 bucket access, are very important aspects here. So we have reached the end of the presentation for today. Any questions we can take up at this point in time? So one of the question is, let's see, first question says, which all services we are going to cover in next blog, next webinar? Yeah, so I would say stay tuned, And if you have any special request, please feel free to put that in the feedback. We'll take into account. We intend to cover a lot more services and very interesting security features going forward. And if you want to see the actual how do we do it, we can of course go to the blog, which has screenshots of instructions step by step how to set up these particular, say, password policy or maybe other this thing. It has AWS console screenshots with numbering instructions and very detailed instructions which can be followed. So I'd like to, at this point in time, there are no more questions. I'd like to thank a lot to everybody who is present here, and looking forward for a subsequent session on that. Thanks a lot. Good night.